Hi, I'm Marcello. I work in the AndroidX architecture components team at Google, and today we'll be discussing the commonization of the Lifecycle libraries. Before we start, just a heads up that this talk is designed for library authors. So if you do develop a library and you want to migrate the library from Java or Kotlin to Kotlin Multiplatform, that you might learn from the same challenge we faced. If you're an app developer, you might not be able to use all of these things in your app development life. However, it might still be interesting for you to know what was the challenge, why we did things the way we did, and the reasoning behind that. So for today, first we will be talking about the Android support for Kotlin Multiplatform that has been announced in Google I/O 2024. Second, we will be discussing the timeline to get the Lifecycle libraries released to stable. And finally, we will be talking about the API challenges. This is going to be the longest part of the talk, and it's going to be mostly code. We'll be discussing a bit of the Lifecycle and also the ViewModel APIs. So in 2017, we introduced the architecture component libraries, and with them also the ViewModel and the Lifecycle libraries. Also this time, we had mostly Java-first ecosystem, and these libraries were designed for this ecosystem. We still were using the XML View UI toolkit that if you have been doing Android for a while, you are probably familiar with. Fast forward to 2024, we did announce that we are officially supporting Kotlin Multiplatform. The word now is a bit different from it used to be. We do have a Kotlin first ecosystem mostly, and we also have the modern UI toolkit Compose. So what does it mean to support Kotlin Multiplatform on Android? There are basically two types of support, the compatibility and the support in itself. For the compatibility, the idea is basically that we are converting libraries that can be used in a Kotlin Multiplatform project. You can basically include this project in your Gradle file, and you can call this code from your common source set, but you might need to provide integration by yourself. That means you might need to write your own lifecycle owner, or you might need to use a third-party library such as Navigation Compose Multiplatform provided by JetBrains. For the KMP support level in itself, that is mostly, it's like KMP compatibility, but there is already out of work, it basically works out of the box. So you can just drop in the project, you don't need to provide any type of integration, and things will just effectively work. Example of a library that has KMP support is Room. You can put it in the project, and as long as Room support the target, you can use this library without any additional work. So let's talk a bit about actually the timeline to get the Lifecycle, these libraries to stable release. The main goal was to get the navigation KMP released. And for that, we have mostly been collaborating with JetBrains. They have been very willing to get official navigation support for Kotlin Multiplatform. And how we basically divide this work is that we start to collaborate with them in January. The whole work went from January to May in 2004. And we start to have syncs with them, try to understand what would be the roadblocks, and we start to remove these roadblocks so they could actually work in the navigation KMP. Basically, what we did is we mapped the dependence from the navigation libraries. And those are most Lifecycle, Runtime, Common, Compose, KMP, ViewModel, and these things, save state, and so on. And we at Google, we start to work in making them stable and converted to KMP ahead of time, so that JetBrains could focus actually in the navigation library. For us, it was very important to actually get the Lifecycle released as a stable, mostly because we did want them to depend on stable APIs on the navigation. So once they had their first alpha navigation release, we want them to be building against a stable Lifecycle common API, so they have a guarantee that those APIs are going to be supported in the long run. So let's talk a bit about the challenge in itself. So if you have been doing Android for a bit, you might be familiar with the Lifecycle events for an Android. You do have the on resume, on pause, and so on. As it seems, Most of the other platforms have similar events. Those are basically mapped through callbacks. So if you're in an iOS platform, for example, you would be mapping something like view will appear to on start, or view will resign active to on pause. For desktop, that's also similar. We can use something like window gain focus to on resume, or window lost focus to on pause. For web, that's a bit different. Like web is much simpler lifecycle-wise. So mostly we map the focus to on resume, and when there is a blue, we go to on pause, and that's basically it. If you're using Navigation Compose Multiplatform, if you're using Navigation Compose Multiplatform, JetBrains automatically does this mapping for you. If you're not using that, you have to do the mapping yourself. So ViewModel provider. So if you use activity and fragments in your project, you might be familiar with the by ViewModels API, which basically allows you to pass in factory and return a ViewModel. It's an extension function that lifecycle owners such as activity, fragment, and nav backstack entry have it. Composable, in case you are doing compose apps, you can use the composable function ViewModel, and you can just return a lambda that's returned a ViewModel. Pass in a lambda that returns a ViewModel. And it returns the instance of the ViewModel. And behind the scenes, all of them are, at some degree, there are other things happening, but in the end, they will always be calling a ViewModel provider. They're going to be passing a ViewModel store, a factory, and an extra, and then calling the get, passing the key and the key class, or a Java class, in this case of the ViewModel. They do also do some other things like keeping a reference, like to not have to access all the time, like lazy and so on, but in the end of the day, it's always going to the ViewModel provider. The ViewModel provider is basically the main API surface if you're using ViewModels. So the ViewModel provider class. This is a simplified version of the ViewModel provider. If you open the AndroidX repo, it's going to be a bit more complicated than that and with more methods and so on. But here we do have a simplified variation of the methods that caused some of the issues that we're going to be covering. The first thing we will be discussing is the constructor. The constructor taking the ViewModel store. The ViewModel store is basically the class that when there is a configuration change, the ViewModel store is going to be retained in memory, and when you ask for a new ViewModel, the ViewModel store is the one caching the ViewModel and give that back to you. The factory is an interface that allows you to create a ViewModel, and the creation extra is basically additional arguments that you can pass in to configure the ViewModel instance during creation. There is the get function, that is the function that orchestrates all of that, takes in a key that is a string, a model class representing that ViewModel, and always return a ViewModel instance. There is a factor interface that is very similar to the get method, actually. Takes a model class, take a extra parameter, and then returns the ViewModel. Here, the factory always creates a new instance of the ViewModel, while the get may create a new instance of the ViewModel, if there is not created yet. There are two different implementations for the factory interface. One is the new instance factory, which is the factory used to create instance of ViewModel using the no-args constructor. And there is the Android ViewModel factory, which is a specialization of the new instance factory that does the same, plus it also supports creating ViewModels that have a single parameter that is the android.app.application. And the companion object that add utilities to the ViewModel provider. So, the constructor. If we take a close look at that, we're going to see that there is a creation extra that by default is empty and is annotated with JVM overloads. The JVM overloads here is important to keep backward compatibility Java and interoperability for the default parameter. Theoretically, if the creation extra is already converted to KMP, we could potentially just move that to Android main to common main, and all of these things should work. The JVM overloads is supposed to work on KMP. It's going to affect only when you build for Android or JVM targets. And things should just work by moving it from Android main and common main. So what we can do in the AndroidX repo is we can actually run this command gradle check API. And this is going to run MetaLava, and it's going to check the API to see if there is any unintended API change that we didn't want to cause. This command will check it on both JVM targets and native targets. So for native targets, if I remember correctly, we do use the Kotlin binary validator from JetBrains. For JVM targets, we use MetaLava. So by running this command, after just moving the file without any additional change, we do get output that says that a constructor has been removed and a constructor has been added. Both of them have the same number of parameters, the ViewModel store, factory, and creation extra. And yeah, if we do look closely, we can see that there was an optional keyword that was added in the last parameter, and this optional keyword stopped existing after we moved the file. So what we can do here basically is we need to figure out why this change happened. So we can take the code before moving and the code after moving. We can take the Java bytecode, we can decompile this bytecode, and we can compare the two of them doing a diff. If we do that, we're going to get this code. And basically the two functions here are what normally you would expect from the JVM overload annotated method. It basically takes the ViewModel store factory or store factory plus default creation extra. So Java clients can call the two of them. The first variant, we're going to automatically pass the empty creation extra. What is interesting here is that there is a third method that the Kotlin compiler is going to create. And this is used, it seems, based on their issue tracker and documentation, for internal optimizations that the compiler can do. The thing here is that this method is actually public and is a syntactic method. Clients will not call that directly, but the compiler might optimize the code that your client is using to use this method. There is also the full constructor marker in the end that clients cannot access directly, but the compiler can. And as it seems, if you do move files or annotated class constructors from common man to Android main, annotated with JVM overload, the Kotlin compiler will not generate the syntactic method, the full constructor marker, and that will be an API change. And basically, if you do have a client that compiled against the old version of ViewModel, and you happen to run it against a new version, that method would not exist, and that would actually crash. So what we can do instead here is that we can fix that by ourselves by manually implementing what would happen here. So we would need to leave the ViewModel, the constructor function as it is today, for Java and Android compatibility. And we're going to introduce a new create method that does exactly the same, and just pass the call forward to the ViewModel provided constructor. So it doesn't do any additional work. And basically here, new clients that use KMP code, they would need to call the ViewModel provider calling the create function. Android clients would still work as it is. And everything that has been compiled previously will still work with any new version of Android ViewModel. So the first learning from this is by just moving files from common to common from any other platform might change the public API. If you do not have any tooling that validates these APIs, you might have an intentional change that might break customers and clients. Ideally, you should have something integrated if a library author, such as the Kotlin JetBrains, Kotlin binary validator, I think that's the name, or MetaLava or something. So next, the get function. The get function is quite straightforward in the signature. Takes the string in the model class. And if we do check the model class, we're going to see that that is a java.lang.class, and that is only available for Java clients. We need to actually handle that. This function cannot be converted to KMP, but what we can do instead is we can duplicate this function. We can change the signature to take a key class, which is available on Kotlin Multiplatform, and we can backforward the call from one to another to be sure that they are still compatible. If you're using the ViewModel provider in a KMP common source set, you will be able to call the get function passing the key class. If you're using Android, you will still have Android or JVM. You will still have available the model class that takes the java.lang.class, and they are compatible. And by doing that, we actually start to receive reports that there has been some, basically there were people that had tests and these tests stopped to work. And the reason this test stopped to work is that they were using mocks. And basically before we had one method that took in 2 parameters. But now we have an additional method that takes 2 parameters, but the last parameters instead of a class is a key class. And mock libraries, normally they are not able to differentiate that by themselves. So they automatically assume that there is an ambiguity and there is no way to define which one you're actually mocking. And yeah, one way to fix that would be to explicitly define the any type in any. But in our case, our learning was to simply not use mocks. So now the factory. Yeah, the factory, like the example before, takes in the model class, a creation extra, and return the view model. We expand the class. We get the java.lang class again. We need to do something similar. Different from before, the get function is actually a final function, and this is actually an open abstract function that you can implement yourself. So we do introduce a new method that takes in the key class, but now is the other way around. The new one actually called the previous one to be sure that the previous one, people that implemented the previous one, the code would still work as expected. And besides that, works exactly the same, and the throw is actually the re-implementation by default if you don't implement it. So the learning here is, if you do have platform types in your public API, such as Java in our case, migrate from Java to Kotlin Multiplatform, you really need to worry about maintaining backward compatibility, and you need to figure out which types we're going to replace that and how we're going to do that without breaking your customers. It might be that you have to duplicate methods. It might be that you can actually sunset some of the methods if they don't make that much sense anymore in your API, but there is a trade-off and you need to figure out by yourself. So the new instance factor. If we expand the new instance factor content, we're going to see that it basically called the model class .getDeclared constructor .new instance. The thing here is that this factor uses the noargs constructor to create instances of ViewModel, and the getDeclared constructor is actually reflection. Reflection is not cheap or available in all platforms. So there is a library from JetBrains that provides reflection on all platforms that's called kotlin.reflect.full. This library is a bit heavy, like large in the APK size and all. And it does provide the create instance method that we actually would like to have. But if we include that in the ViewModel library, that would increase considerably the APK size of everyone that actually used that ViewModel. And it was a bit too much to introduce a whole library that's quite large because of a single method to create instances. So the learning for this case for us has been not all APIs are worth to implement in all platforms. Some platforms are really good doing something, others are not, or they have different trade-offs. So you need to figure out which APIs are actually worth it to bring to these platforms. For the Android ViewModel factor, which is the specialization for new instance factor, that's going to be quite quickie, actually. If we expand the content, you're going to see that it takes in the application android.app.application. As the name suggests, is an Android-specific class, and there is no actually way, like, this doesn't translate well to other platforms. Also, it would be very weird to have an Android ViewModel factory class in your common source set. So the learning here is that not everything that you have today of features needs to be necessarily commonized. It's okay to actually rethink some of them and not commonize them. Okay, so let's take the ViewModel provider now and actually make it available to all platforms. As we discussed before, we're going to be commonized just some of the APIs, not all of them. And we do that by adding the expect keyword in front of the class, in case you're familiar with the KMP expect actual keywords. And each platform, or each platform that requires this implementation, will have a variant of this file that's going to have the actual class ViewModel provider. Basically, we are going to be converting these three, the function get, the factor interface, and the companion object. And the thing here is that the function get is basically shared between all platforms. So the first assumption that you would have is, okay, some of the constructor, the new instance factor, the Android ViewModel factor are specific for Android or JVM. We don't need to port that. They're going to be put in the actual class of that platform, but you would assume that, okay, the get method can be shared, so maybe we can implement the full implementation and just call it a day. But actually, expect declarations don't support the full implementations, so you need to handle that by yourself. So if we do count the number of ViewModel provider, probably this is from like 2 or 3 months ago, maybe there is more now, per platform, we would basically get 3, the desktop, the Android, and the non-JVM. We really don't want to triplicate that. So we want to have one single behavior implementation and just share that and just have to test it once and be happy with that. So what we can do here instead is we can introduce a new class that's going to hold the behavior and data of the ViewModel provider. We are basically moving the content of the ViewModel provider to a different class. And the actual implementation of each platform, in this case is the Android one, the actual ViewModel provider class, we'll just create an instance of this ViewModel provider imp, and it's going to pass forward all the calls to that class. So we do that by actually introducing a private constructor that takes in a ViewModel provider imp. This ViewModel provider imp has all the implementation from the ViewModel provider that used to live in this class, and we are just calling imp.getViewModel when get is called. And this class, basically, nothing really changed here, but there is one thing I want to call attention, which is this model class. As we discussed before in the previous slide, the Java.Language class is not available on the KMP. So we had to change that to a key class to make it work, which seems a reasonable thing to do. So factory.create now takes the model key class, model extra, and everything work. And that caused us to revert a 2 years old fix of an issue when you had the sugaring enable in your project with compile only to specific libraries. So for example, if you use something like leak carry, that would crash your project. And this was fixed on 2.8.2 of Lifecycle, but let's see how to actually backport the change. Basically, we changed the factory.create model class, model extra, to an expect function that's going to be called createViewModel, receiving all the parameters. The expect function works similar to the expect class, but yeah, actually works exactly the same as expect class. And for all platforms that are not Android, we're going to simply call factory.create model class.extra as before. However, for Android, for compatibility issues, we need to handle that by ourselves. So we're going to try catch the method, and we're going to basically brute force each one of them to see which one works. So we're going to start it with a create model class with a key class and an extra. If that throws an abstract method error, we're going to try that with a Java class.extra. If that throws an abstract method error because the sugaring removed this method, we're going to try the model class with the Java, which is the original method that used the empty default creation extra by default. And that works and fixes the problem. So what we did here is basically we have this ViewModel provider class that is separated by the 3 platforms, desktop, Android, and non-JVM. And we have this shared ViewModel provider implementation, which is an internal class that we use to share behavior and data, which calls a specific createViewModel for each platform to make sure that the Android one behaves as it used to behave. So the learnings here is, first is that expect classes cannot have default implementations, so there is an issue open, and I hope the JetBrains fix that. But for now, you do need to implement that by yourself somehow. So it can be functions, it can be classes that extract if you need behavior and data together or whatsoever. The sugaring modification can cause side effects that is very tricky to track. Like you actually don't know exactly if you don't know the problem, it's very difficult to actually see that this will cause a problem because it happens after the sugaring and modification happen in the source code. Once you know the problem, you can write, like we did, tests to ensure that this will never happen again. But you need to be aware that touching your code and commonizing your code can cause problem in clients that use the sugaring modification in some cases. And you can mix and match expect and actual keywords to share as much code as possible. But just a heads up here is that if you do use expect and actual, like you saw before, you're actually creating more branches of behavior. So depending on the platform, the combination might change, and that's a different behavior. This means that you probably want to have more tests that covers all of these different behaviors paths. So ideally, you do want to write as much as possible common code, and you just leave the expect and actual for case that you really, really have to specialize for the platform, and you write tests to cover all the platform behavior. So for the ViewModel class, the ViewModel class is probably the most known API from the ViewModel library. Everyone that uses the ViewModel library will extend from the ViewModel class, and it's going to be retained in the memory, the model as probably you're already familiar with. The interesting APIs here are not the ones that most people use the most, like uncleared, is actually add closable and get closable, which are APIs that allow you to bind the resource to a ViewModel lifetime. So basically, this API allows you to say, I have this object that is a closable. I want this closable to be closed when the ViewModel is cleared. And when the ViewModel uncleared is called, everything that has been added to it was a closable is going to be closed together. You can also use the getClose, passing the key string to return a closable that has been previously associated with the ViewModel. We actually use that to write the ViewModel scope. The ViewModel scope is a closable included using the add and get closable APIs. The ViewModel scope is a pre-configured coroutine scope made for UI operations, basically. So you don't need to create one and do all the dispatcher main with supervisor job and so on. So for the add closable, if we expand the closable package name, we get the java.io.closable. As we've seen before, Java types are a bit difficult to handle, like compatibility-wise. So we need to change that to something else. Java.io.closable actually extends another interface, I think, called java.io.autoclosable. And the autoclosable API has been backported to KMP. So we can change those APIs to actually use the autoclosable. Because closable implements autoclosable, that maintains binary compatibility at some degree. The Kotlin.autoclosable is a type alias that's going to target the correct implementation based on the platform. So if you're running JVM, you're targeting the java.io autoclosable anyway. If you're targeting other platforms, you're actually introducing new autoclosable interface. That works well for the point of view of binary compatibility, like they're compatible. And for the add closable that takes in the key and the get closable that takes in the key, we can just do the change because these APIs we were very lucky and these APIs were not stable when we actually did this conversion. However, the first method, the add closable, is actually a stable API, and we want to be sure that this still keep compatibility with whoever used to call that method. And we do that by introducing a copy of this method, duplicated, that actually still takes in the java.io closable. We annotate it was deprecated, and we set deprecated level was hidden. So you cannot call this method by yourself. If you try to call add closable, passing any closable instance, you automatically go to the out closable because they implement each other. But if a library has been compiled against the java.io.closable, we want to be sure that this library still works with new versions of the ViewModel library. We don't want to ask everyone that build a library that use this API to update their API with our specific version. So we do that by the deprecated hidden and leaving that there. Also, because we did that, and the java.io.closable is a Java-only type, we do need to duplicate the code again. We need to introduce a new expect class. We need to introduce, in this new expected class, Android variant that has that method, and that method does not exist in other platforms. So if we count the number of ViewModel files again, we get the JVM and the non-JVM. The JVM one contains the hidden method, the non-JVM doesn't. we do exactly the same approach as before. We create the ViewModel implementation instance, and this ViewModel implementation basically takes all the behavior and data from the ViewModel. It used to live here, and all the actual implementation of each platform will simply call and pass forward any method call to this new instance. So the ViewModel implementation actually works quite well with KMP, almost without any change. But there is one thing here that actually is not supported by KMP, which is the synchronization. The ViewModel implementation uses synchronization to ensure that when you add a closable or get a closable, you are safe that that will be a unique instance. And because that's not supported by KMP, we do need to implement that by ourselves. So JetBrains does provide a library that has synchronization support for all platforms. But this library is called Atomic Foo, and this library is experimental, and this library has a package inside it that is locks. And if you do check their README file, they explicitly about how experimental that is. Like the library is experimental, and the package is experimental within the experimental of the library, and there is no ABI guarantee or any guarantee at all. Yeah, so we cannot put that in a stable artifact like Lifecycle and ship ViewModel and ship that. So we need to implement that by ourselves. In this case, we do want to have an API that is very similar to the API that we are familiar with. So once, hopefully, this gets stable, we can actually replace that to use the Atomic Foo one. So how can we do that? We can introduce yet another expect class, a synchronized object. We can introduce a final inline fun synchronized that calls a synchronized implementation that is going to be an expect function that has the implementation of this synchronization. You might find a bit weird that there is a synchronized and a synchronized impl. And the reason that we need to have those two is because we use the contract to give more information to the compiler when the synchronized function is called. And as it seems, contracts are not supported inside the expected declarations. So we had to create a new function that's final, create an expect function, and then call the expect function from the final function. And these allow us to work around and be sure that the contracts works as expected. We can still use contracts and still have the expected implementation. So for GVM implementations, it's quite simple. We can just call the Kotlin.synchronize, the API match. So the API signature match. So we just pass forward the parameters, and that's it. For native, though, we do need to implement that ourselves. We won't be covering all the implementation, but I will just call attention for some specific points. Basically, how it works is that the synchronized impl receives the synchronized object. It's going to call lock, call an action, and unlock when it's unlocked. And this lock and unlock, we'll need to use native APIs to understand when to lock and unlock the resource. So if we go to the native implementation and check the synchronized object implementation, expanding it, there is a bunch of things that have been omitted, but you will notice that there is this annotation called experimental foreign API. And the first thing is that even us trying to avoid the atomic foo locks that is very, very, very experimental, we still had to use experimental functions to actually use that, but we did avoid adding a new dependence that would cause other buttons. The second thing is that the experimental for an API basically is Kotlin Multiplatform is really powerful, and one of the main advantages of Kotlin Multiplatform is that you can have interoperability with the platform system. So you can call native APIs, and you can take advantage of that APIs that the platform in itself is providing. You don't need to reinvent the wheel and write bridges and connect with everything all the time, every time. It's also more performatic to not have to do this bridge and do the native calls itself. The downside of that is that you do sometimes need to touch these APIs, so you might need to learn a specific platform APIs and have to handle that by yourself. And some might be still not, the API that you consume that from Kotlin might not be yet stable. So ideally, with more libraries and APIs being converted to Kotlin Multiplatform, you're going to end up in a situation where these APIs will be all uncommon and you can just call them and you don't need to worry about these things. But while we're developing libraries for this ecosystem, today, at least, you would need maybe to implement them. Another interesting thing here is that you're going to see that there is an expect val for a integer. And the reason that we have that is because this mutex recursive flag actually is defined slightly different depending on the platform. So basically, this flag has different numeric types depending on the platform, and on Darwin, this is a signed integer. On Linux, this is an unsigned integer. So we actually need to make expect actual, convert them to the correct type. Now, there is an open issue to improve that experience, but yeah. Today, that is what works. So, the ViewModel scope. The ViewModel scope uses the APIs we saw before, the synchronize that we created internally, the get closable and the add closable. And it returns a closable coroutine scope, which is an internal class that implements out closable. Whenever the close method is called, the coroutine context cancel is going to be called together, so we assure that the coroutine scope does not overleave the ViewModel once uncleared happen. You can actually use this API to write your own extension in the ViewModel if you like. The interesting point, like this mostly work, but dispatcher main is not available on all platforms. So we cannot just call dispatcher main immediately here and expect things to work. This might throw, and they might throw different errors depending on each platform. So we need to handle that ourselves again. We do that by creating a new function called create ViewModel scope. This is an internal function. And this create ViewModel scope, different from before, we're not going to use expect and actual and do it different for platform. We're going to actually handle those errors on the common source set. Basically, on Android and any platform that has a dispatcher main, we do use the dispatcher main. If there is a not implemented error, normally in environments like native Linux, we actually fall back that to empty coroutine context, which is the default coroutine context. So we basically don't do anything there, we just use the default and that's it. If we do get a legal state exception in environments such as GVM desktop using Swing, we do the same, we fall back to the empty coroutine context. Finally, we do return the closable coroutine scope, passing the dispatcher plus the supervisor job, again as before. So the learning here is not everything has to use expect and actual declarations. You might use that when you find valuable, and it's very powerful, but sometimes it makes sense and it's fine to just implement the method and handle the case yourself. So do that case by case, depending on what you need. So the three main key takeaways from our experience with the lifecycle libraries are, the first is that you do need to strive to find a balance between the minimal change in the API and the best possible common API. We do want to provide a really amazing common API for Kotlin multi-platform clients, but at the same time, we do have a responsibility with all the apps, probably all the apps that you folks are building, that they would still keep working with new versions of the library. So that is something that you need to find a balance. That might not be that extreme for other library authors, but for us, that's a big deal, and we want to be sure that there is minimal impact on the Android development ecosystem. You can reuse the knowledge, so if you do have develop a library and that is already being used by hundreds, maybe thousands of people, you can actually learn from the experience of these people and talk with them and try to understand which APIs make sense to convert. Maybe there are APIs that can be sunset. How should you do this or that? So you can reuse the knowledge of what you already have. You not necessarily need to rewrite everything in a Kotlin way of doing things and just go randomly in that. So my suggestion here would mostly be reuse what you have, and then after that, you think about how can you improve things. Also, in case you have to duplicate methods like we had to do for binary compatibility, try to keep those API signatures as consistent as possible. So that helps with developer discoverability, so they kind of have a better day finding what method to call, and so on. Last but not least is that Kotlin Multiplatform is very powerful. We did had a lot of annoying roadblocks that we had to deal with. At the same time, we also converted a library that has been developed 7 years ago for Java all the way to Kotlin Multiplatform without breaking binary compatibility and make that run everywhere. So that just shows how much flexible and how much powerful Kotlin Multiplatform is already today. That's all I have today. Thank you.